Hi, I'm Engineer Muhammad Rizwan. I'm online math and physics tutor. In this video, we will learn about the distance of a point from a line by scalar product approach. Let's start our work. First of all, we read our question. Find the distance of a point from a line by scalar product approach. And we have given a point A whose position vector is I plus j plus k. So we can write the position vector is as in vertical column 1, here is 1, here is 1, here is 1. So we write plus 1 plus 1 plus 1. So our line is passing through point B whose position vector is 2i minus j plus 2k, and also passing B and C. Our line is passing through point B and C whose position vector has been given 3i plus j minus k. So we start the solution of this question. First of all, we draw its figure. As O is our origin, and suppose A is here, so its position vector is as. We put arrowhead here. I make point B and I draw its position vector as. I draw B and C. I draw a line which shows its position vector. As our line is passing through point B and C, line is passing through point B and C. Our requirement is to find the distance of this point from this line. As this is a line, then we put arrowhead. So distance of this point from this line will be a perpendicular. This is a perpendicular. We draw perpendicular from this point A to this line, and after this we find the length of this perpendicular, which will be the distance of our point from the line which is passing through point B and C. We give it name as D, so AD. What is OA? Means position vector 1, 1. This can be represented as. So for position vector of B is 2, minus 1 and 2. Position vector of C is 3, 1, minus 1. As we know that this BD is perpendicular, so BC is also as our line. This line is perpendicular to this, so line segment is also perpendicular to this. So our BC is perpendicular to AD. BC perpendicular, vector BC perpendicular to AD. Here we make BC, and we put arrow as we know that if two vectors are perpendicular, then their scalar product is equal to 0. So we can write BC dot AD is equal to 0. We give this name as A. We give it different name, means small a. First of all, we find BC, and after this we will find AD, and at the end we take the dot product. BC. We make figure B for BC separately, B, and here is C, and here is O. We have three factors: OB, BC, and OC. We recognize which one is our resultant. Which one is our resultant? So here, head is meeting with head, and tail meeting with tail. So our OC is our resultant. So by head to tail rule we can write OC is equal to the sum of all other vectors and BC. As our requirement is BC, so we can write BC is equal to OC minus OB. OB is this 2 minus 1, 2 minus, first we write OC 3, 1 minus 1, and OB is 2 minus 1 and 2. We subtract 3 minus 2, answer is 1. 1 minus minus plus, this will be 2. Minus 1 and minus plus minus. Minus 1 minus 2, answer will be minus 3. This is our BC. This is our BC. So now we find AD. What will be our AD? We consider this AD as resultant. So for this purpose, head is meeting with head. So we consider for this AD we consider AO, means we make other vectors AO here as A, O, B, and D, and this is perpendicular, so this and this. So in this case we can see AD head is meeting with head and tail meeting with tail. So we can write that by head to tail rule, AD is equal to AO plus OB plus BD. So as we know that this is OA, position vector. So our AO is a negative vector, its direction is S and its direction is opposite. So our AO will be the negative of OA, negative of OA. OA plus OB plus BD. Here we know that BC and BC parallel to BD. Vector BC and vector BD are parallel. If two vectors are parallel, then they are scalar product of each other. We can write BD according to definition of parallel vectors. This is BD will be the scalar product of lambda BC, or we can write BC is equal to lambda prime BD or lambda. So in this case, as BC value has been calculated, so we can write instead of BD, BC minus 111 plus what is our OB, 2 minus 1 2 plus lambda, our BC is 1 2 minus 3. So we multiply minus 1 to this whole plus 2 plus lambda. Lambda will be multiplied to whole 1. So minus 1 minus plus minus minus plus 2 lambda. So we write minus 1 plus 2 minus 3 lambda. We solve it. Minus 1 plus 1, 1 plus lambda, and minus 1 minus 2 plus 2 lambda, minus 1 plus 2, 1 minus 3 lambda. This is our AD. This is our AD in form of lambda. Here lambda is unknown. First of all, we want to find the value of lambda. For this purpose, we take the dot product. We will take dot product and find the value of lambda and put the value of lambda here, and we get this vector, and after this we take its magnitude by using the formula. BC dot AD is equal to, our BC is equal to 1 2 minus 3 dot 1 plus lambda minus 2 plus 2 lambda 1 minus 3 lambda. We multiply 1 to this. We multiply this to this, and we multiply 2 to this, and minus 3 to this. So we put positive 1 into 1 plus lambda plus 2 into minus 2 plus 2 lambda, and I write here plus and minus 3, 1 minus 3 lambda. Here is 0 because BC and AD are perpendicular, which is equal to 0. 1 plus lambda minus 4 plus 4 lambda minus 3 plus 9 lambda minus 3 minus 4 minus 7 plus 1 minus 6 and plus 14 lambda. So we, after solving, we get lambda is equal to 6 over 14, and the value of lambda is equal to, after simplification, 3 and 7, 3 upon 7. 3 upon 7, lambda is equal to 3 upon 7, which is our answer. So we put this lambda value in our AD. So in this way we will find exact value of AD. Here is unknown. So we put the value of unknown in AD and we get this vector. AD is equal to 1 plus 3 by 7 minus 2 plus 2 into 3 by 7, 1 minus 3 into 3 by 7. This way we simplify this and find 7 plus 3 by 7 minus 2 plus 6 by 7, 1 minus 9 by 7. So after solving AD, what is the value of AD? AD is equal to 10 by 7 minus 14 plus 6 by 7, 7 minus 9 by 7. 10 by 7 minus 8 by 7 minus 2 by 7. This is our AD. Now we can write AD as 10 by 7 I minus 8 by 7 J minus 2 by 7 K. As we know that if we have r vector xi plus yj plus zk, then its magnitude is equal to x square plus y square plus z square. Now we take the magnitude of AD, which is equal to d, distance. AD magnitude is equal to d, 10 by 7 square plus minus 8 by 7 square plus minus 2 by 7 whole square and under root. D 100 by 49, 64 by 49, 4 by 49. So here 168 by 49. We know that this is 7 equal to 7, under root is equal to 7, then we do prime factorization of this to 8, 4, 2, 4, 1, 41, 42. So so we do 42. 2 has square, then it will come out and square will be cancelled out due to under roots. Then So this is our required distance. The distance of this point A from this line is equal to 2 into under root 42 upon 7. I hope you have learned this method, and if you have any confusion you can contact me on my WhatsApp number, on my Skype, on my Facebook page, and I will try to help you. Thanks for watching my video.